Okay, I'm going to review increasing, decreasing, relative mins and maxes, and some of those other items with you right now. So when we are looking at a polynomial, when we find the zeros, those should be relatively easy, right? They're the x-intercepts, but we need to make sure we write them correctly in our answer blanks. So I personally like to move from left to right. So the first zero I see on the left-hand side is x equals -5. And this clearly has a bounce, or is the top of a parabola. It has a multiplicity of 2. The next zero I see is at -4. I'm fine with you putting a comma. That x equals at the beginning is good enough. And then that's x. I just said you don't have to write it twice. That's -4. It's going straight through, so that multiplicity is 1. You technically don't have to write multiplicities of 1. The next place it crosses the x-axis is at 0. It looks like a cubic there. So 0 with mult 3. And then it looks like the last place it hits is +3 with mult 2. When you're finding the degree, we will try to give you pretty much straightforward polynomials that look like this. When you're finding the degree, you can add the multiplicities that you just found, and that'll give you the degree. I need you to know that, like, when you move on to harder classes like calculus and stuff, if this graph then did like a turn and had another parabola up away from the x-axis and then came back down and did this, it would have a higher degree than the one we're about to graph, but we'll keep it pretty straightforward on our tests. So we have 2, 1 more, 3 more, and 2 more, right? So our multiplicity is 2, 1, 3, and 2. So degree 8. Domain. All polynomials cover the entire x-axis, so all real numbers for the domain. And the range, this one, remember when we screenshot things from Desmos, it is implied that there is an arrow here, and it is implied that there is an arrow here. So this one is going down forever. And range, it's always negative numbers first. It's smallest numbers first. It's bottom to the top. So parentheses negative infinity. That's a terrible infinity. Oh my goodness. Good enough. And then it goes all the way up to the highest point, and we are looking for y values. So the highest point I see is right here, and the y value is that 444.694 number, and it does touch that, so that needs to be a bracket. It is included. The y-intercept, I scan the y-axis and I see that it hits at 0, and intercept is written as a point. Okay, maximums and minimums. So a maximum is the top of a hill. So here's a hill, it has a top. Here's a hill, it has a top. Here's a hill, it has a top. Cubics do not count as either. Cubics are not hills or valleys. So there are 3 relative maximums. That's the relative term. If I was looking for absolute maximum, it would just be this one. But relative to the points around it, the point -5, 0, it's a point. The point -2.573444.694, and the point 3, 0. Those are all relative maximums, tops of a hill. Relative minimums are bottoms of a valley. So here's the bottom of a valley. Cubics do not count. Here's the bottom of a valley. Those 2 points are relative minimums. Relative to the points around them, closest to them, they are the lowest. Those are our minimums. Okay, increasing, decreasing. We are talking about, as you read your graph from left to right, is your pen or your finger going up or is it going down? Obviously, there's more to it that you will learn in calculus to do with increasing and decreasing, but for us, we just have to read the graph. Increasing and decreasing is a domain. These should be x's only. I should not see a single y value written in your increasing or decreasing answer blank. So from the left, if I start tracing my graph, clearly I am going uphill. Going uphill is increasing. From the left is negative infinity on the x-axis, and it is going uphill until it gets to -5. Parentheses when we do increasing, decreasing. At -5, it starts going downhill. It is decreasing from parentheses, -5, until the x value of -4.41, parentheses. Then it turns, so it's going back uphill. This is what you're going to do a lot of, going from here to here to here to here to here to here. So now it turns, it starts at parentheses, -4.41, and it is increasing until the x value of -2.573. From there, -2.573, it is decreasing. Cubics do not change your increasing, decreasing. It is decreasing until the x value at the next minimum. Your minimums and maximums will be the turning points for these. And then from there, it's increasing till the next maximum. And then from that maximum, it is decreasing forever. And I understand that it's going down, so you all want to put -infinity, but it's going right because these are only x's. So until positive infinity. This was our first example. Okay, example 2. Pause the video, draw this somewhere, or just look at it and fill in the answer blanks on your own. Pause the video and fill in the answer blanks on your own. Here I go. Zeros. X equals, once is fine, but don't forget it. -3 with mult 2. It hits at 1 with mult 2. And it hits at 4. So if I add up my multiplicities, 2 plus 2 plus 1, this is degree 5. Domain is always all real numbers. It covers every x value possible. Range, remember the implied arrow here, it's going down forever, and the implied arrow here, it's going up forever. So the range for this one is all real numbers also. Y-intercept, if it's not 0, 0, we have to show it to you in a label. If these points are like really close together, look for the one where x is 0, right? Like I understand sometimes these points get close together and it can get confusing, but you know what's not confusing? Finding where x equals 0. So 0, -36 is the y-intercept. If you haven't paused this and tried it on your own yet, again, pause it and try it. Maximums, top of a hill. Minimums, bottom of a valley. Notice I didn't add these little labels to those points because they're clearly already labeled. So don't just think that like only these are the important points. Anything that you can see is an important point. So there is no set number of how many mins, relative mins or maxes there might be. All tops of hills and all bottoms of valleys. Okay, from the left happens to be increasing again from -infinity until -3. Then it's going downhill from -3 until the x value of -1.91. Then it's turning, it's going uphill from -1.91 until 1. Then it's going downhill from 1 until 3.19089. Then it's going uphill from that x value until infinity because it's x values. So here are 2 examples of increasing, decreasing problems that you guys can use to practice. Hope you're doing